The Zero Planet, the story of Vulcan. Hello, welcome to the channel. In 1859, Edmund Lescarbault was observing the sun through his telescope. As he recounted, he unexpectedly saw a black spot moving across the solar disk. He was convinced that it was the shadow of an object that many astronomers around the world were searching for, a new planet preceding Mercury, one that could be called the Zero Planet, the so-called planet Vulcan. Today, I'm going to tell you its story. This whole narrative begins with the discovery of another planet. Let's talk about Mr. Leverrier. Leverrier was what we would now call a top astrophysicist. He had earned the respect of the entire scientific community by achieving something unthinkable, predicting the existence of a planet. Let me tell you, armed only with paper and pen, Leverrier set out to calculate how the orbits of the planets should be if they followed Newton's law of gravitation. This not only required taking into account the attraction exerted by the sun on the planets, but also considering how all the planets attract each other, making it a very cumbersome calculation. But the results were good. This simulation of the solar system fit perfectly with everything seen in the sky, except for one planet. Uranus was moving strangely. The calculated orbit and the observed orbit in the sky didn't match. This was something that some astronomers before Leverrier already knew, but he wanted to find its origin. What made Uranus move like that? What was it that he hadn't considered in his simulation? At first, he thought he had underestimated the influence of Jupiter and Saturn, but more refined calculations ruled out this idea. Finally, Leverrier reached the critical point. Maybe, he said, what is happening is that there is another planet, unknown until now, that is gravitationally pulling Uranus, and I'm not taking it into account. Leverrier set the mathematical machinery in motion. Okay, if this is the real orbit of Uranus, how should the new planet be to reproduce it? What should its orbit be like? What mass and size should it have? Through this computation, Leverrier obtained, among other things, the position that this new body should have in the sky. He only needed to ask a German astronomer to look in that area of the sky to see if they found something new. And, folks, that's how Neptune was discovered, with just a 1-degree error. How much is 1 degree of error? Well, imagine that I'm aiming at a spot like my pinky finger, and I'm wrong in the direction by just the width of that finger. That's a degree of error. Now that's some real fortune telling. And, to be fair, I must say that Leverrier wasn't the only one behind Neptune. Adams and Airy, British astronomers, came close to discovering it. There were even earlier scientists who almost identified it by chance, including Galileo himself. The thing is, Neptune is so far away and therefore moves so little that it was very easy to mistake it for a star. So it's not surprising that this was the first planet discovered through mathematics, which led Leverrier to another promising mystery, the precession of Mercury. You may not know this, but planets not only rotate. Let's say their rotation also rotates, a movement called the precession of the perihelion, the same phenomenon that causes spinning tops to wobble. Mercury is the planet that exhibits this movement the most, with a precise rate of 575 arc-seconds per century. How much is that? Basically, it means that this rotation of the rotation, this precession, completes one full revolution approximately every 200,000 years. Well, it's an extremely slow process, but even though it's slow, it's a measurable and, above all, calculable movement. Because what causes this precession of Mercury? In broad terms, it was thought that the other planets were to blame, that they pulled on Mercury, introducing a disturbance that caused this movement. So Leverrier decided to check it in his simulation of the solar system. He obtained what the precession of Mercury should be, compared it with observational data, and, problem, they didn't match. The theoretical prediction was slower, with a difference of 43 arc-seconds per century. In reality, Leverrier obtained a slightly smaller discrepancy, but the important thing was that it was large enough for him to say, oops, this is it. Because if my calculations are failing, could it be because I'm not taking a new celestial body into account? And that's how Leverrier, once again in his life, proposed a new element of the solar system, a body or bodies orbiting very close to the sun, perhaps in the form of an asteroid belt. Leverrier asked astronomers to pay attention and see what they found near the sun. It didn't even take a year for the first detection to occur. Here comes Mr. Lescarbault, an amateur astronomer who swore to Leverrier that he had observed the transit of a new planet. I remind you that we are in the 19th century. Photography was decades away. Leverrier only had this guy's word, but I imagine his data were precise enough to earn his trust. Decided, he presented the results to the French Academy of Sciences, who echoed the discovery: a planet is found before Mercury. A planet they called Vulcan. From here, other amateur astronomers claimed to have detected Vulcan passing in front of the sun, and some even appeared saying they had observed it years ago but hadn't interpreted what they had seen correctly. I suppose that, combined with Leverrier's reputation, the man who discovered Neptune solidified the idea of Vulcan. It appeared in the New York Times as one of the great discoveries in history and even appeared in some books of the time. Yes, the list of planets became Vulcan, Mercury, Venus, Earth, Mars, etc. Now, why don't we keep saying the same thing? What happened to this planet number 0? In short, it didn't exist. Leverrier used Lescarbault's measurements to make a specific prediction of its orbit, including when its transits would occur. Leverrier died shortly after and never saw the results. When astronomers from around the world followed his instructions and aimed their telescopes at the sun to see Vulcan, the planet didn't appear. Unlike with Neptune, none of Leverrier's predictions came true, at least in ones that all astronomers agreed upon. There were still amateurs claiming to have seen Vulcan, but their measurements were contradictory, and some even saw 2 planets instead of 1. The explanation for these sightings? I don't know. Sunspots? Imperfections in the lenses? Suggestion? Maybe real Vulcans? In any case, this wasn't a big surprise for astronomers of the time either. One of the arguments against it were the eclipses. How was it possible that no one had seen such a large object so close to the sun in the clarity of solar eclipses? Vulcan was a risky idea and was discarded. And yet, in a certain sense, the search for it never stopped. Remember to subscribe to continue seeing more content.